Okay, let's start. Hello and welcome, guys. So far, we have learned how to use functions and even make our own functions. But as we do more programming and build our portfolio, one of the things that's going to happen is that we're going to end up with creating a lot of functions. And to handle them in less cumbersome manner, we introduced concepts of modules and also learned how we can create these modules. But what about the data that we use in these programs or the functions? Up until now, everything we have programmed has stored information in memory. That is, once the program is ended, all information gathered from the user or generated by the program is lost. So file input output is the ability of a program to take a file as input or create a file as output. This allows us to save our data for later use. So in today's session, we are going to learn about this concept of file handling. By the end of this session, you will realize how this allows us to quickly and easily deal with large data sets required for various projects. And today's session was the topic was decided by you in the voting. Most of you polled on file handling rather than error handling, so that's you guys chose this topic. Okay, so let's begin. So every operating system on a computer has its own way of handling files, and Python handles by providing an operating system independent way of accessing files called file handle. And the way that is done is by using the special command open and giving it a name of a file, and giving it a command. So there's two portions to it. Open is a method. It has this parameter that is the name of the file or file name, and this optional parameter, and we're going to talk about that optional parameter. So in this particular case, the function open is going to open a file handle that is an access into a file. And that file in this case happens to be a text file given by for names.txt. The file should exist in the same directory as the Python script that you are writing. Otherwise, full address of the file should be given instead of just saying names.txt. And the second optional argument here is access mode, in which the file shall be opened. In this case, we have a W here that says that it's open for writing. So W for writing. I'm going to be able to write into the file that is given by this name here. There are 4 different modes of opening a file. If we, the R is the default one. If there's no argument here, by default it would be R, which is a read mode. And if the file is not there, it will give an error. The second mode is A for appending or writing to existing file. If the file doesn't exist, it will create one. If the file exists, it will add to the content that is already in there. The third option is W, as you see here. It is also for write mode. If the file doesn't exist already, it will create one. If the file already exists, it will override all the contents that are in there. And here I have bound that file handle to a variable named name handle, so it's easy to refer back to using this reference variable. The name handle is the handle that gets into that file. That name handle then allows me to use the file or get access to the file. So for example, I could write a little loop that says to the user, type in a name, and I write it into that text file by again using the name handle and the dot notation, and then the write command. Name handle.write is the method or the command. And the little extra character here is a string that just says to the carriage return or the next line, or to start a new line after the end of this particular line. I could do this as many times as I want. In this case, I was just going to be, it was just going to be 3 times given by this range 3. But what I'm doing is I'm writing directly into a file, in this case called name, things that I'm inputting on the terminal. So as I provide information on the terminal, they are going to get stored on the file. You can imagine also doing computations and writing them away into a file in the similar way. When I'm done, I close the file handle with that command by invoking this method close. Again with name handle.close, because that name handle is the name of the handle that I had set up earlier here. That is just an introduction. Let's go into the coding portion. I shared this Colab with you like I usually do. File handling, there are so let me give you brief like scenario on why the problem exists with working with data. Okay, so in this section I have I have input command, and that is stored in the name just like we saw in the slide earlier, and I'm printing that information. It's pretty simple. It will ask me for information, and whatever name I use, let's just say San, and it will say hello San with that print statement, right? There is nothing new here. Notice that running this code has a desired output. The user can input a name like I just did, and then I get the expected output with hello San. Now let's go. What if we want to allow multiple names to be inputted? We want to put that inside a loop, like in this case for loop, and inside for loop I want to ask a new name every time, and then once I get the name, it is appended to this empty list, right? And then after that input is completed, there's another for loop just to print it out, and like that. So first San, let's say second is Man, and then third is Tua, right? And every time it will just say hello with that name. Nothing new here as well. We're just using for loop to iteratively ask for information. Those are getting stored in this names one variable. You notice there are 3 different prompts for input. The append method is used to add the names into our empty list every time within the for loop, and the next for loop then prints those names to the output in a sorted manner. So I entered San, Man, and Tua, but how I got was alphabetically sorted according to names. Again, nothing new here, not too complicated. I could do the same thing with list comprehension in this example. San, Man, and Tua, and then I get the same output with list comprehension as well. We also covered list comprehension, so this should not be anything new here. The results are same as the prior block of code here, if you compare. Now I'm gonna do something interesting here. Okay, so you see here, everybody's seeing this connected to on my Colab screen. I'm gonna just click on this and disconnect from Colab for now. Yes. Okay, so I'm not connected to the Google Colab server. So interestingly, when I try to run this, any of these cells, let's just say I want to access names too. Okay, so I will create a new cell, and it should be there, right? But what happens is it connects to the Google server again, new resources are allocated, but that name is gone, it's no longer stored. And we introduced this concept of garbage collection earlier in session 2 or 3. That is what is happening here. The variable that was stored in the memory is no longer available because the runtime or the resources are gone, so the memory is no longer binding to this session here. So the point here is it is getting garbage collected, and we lose that access to that variable once we disconnect the session. Similar things happen if you work with your personal IDE on your laptop. So what we need, you can realize from this, like what we need is we need some file input output system to store this information. After our program, we put that information in the file somewhere, and then we need the ability to come back to that file, extract that information from the file, and then put it in our runtime so that we have the data available all the time. So that's where file input output or file handling comes into play. So to be able to do that in Colab, especially in
excuse me, sorry to interrupt you.
Yes.
Say that again. So how can you make it available?
With the file handle, with the like all these examples I'm going to show you.
Okay.
With file handle, input output file handling in Python, or maybe in most of the other programming language as well, there should be some file handling setup done already, right? And that will allow you to store information into an external file and later come back and get access to those data from that file. And with these examples here today, we're going to learn how to do that in Colab.
So external file meaning what, in this computer or in your local computer?
Yeah, in our case, our files will be stored in Google Colab. I mean, Google Drive.
Oh, okay.
Okay, so if we we are using Colab, that's why it gets stored in Google Drive by Google. But if we are not using Google Colab and using any other IDE like PyCharm, then it will store in your local memory on your computer. That's what I mean by external files. External to the interpreter, right?
Yeah, got it.
So especially on file handling portion for Google Colab, when we are dealing with file handling using Google Colab, we have to do this setup step number 2 in the notebook. And by setup, I mean I have to load or mount Google Drive, somehow get connected to Google Drive, right? So you see here Google Drive, my drive, I have several folders and files, and inside Python 101 training I have multiple files here, right? I will delete some files and have other files here, but yeah, that's okay. What I'm trying to say is this is where I will show you, I will store my files from Colab into my Google Drive, okay? So to be able to do that, I have to do these 2 steps. The third one is I'm just listing out the directory after getting connected to my Google Drive. So first, I have to mount Google Drive, and that is the command to mount. I have to import Google Colab. From Google Colab, I have to import Drive, and with drive.mount, when I run this, it will show me this prompt and connect to Google Drive. It will show me choose account, that is my account, continue with some access, additional access to your Google account, continue, and it will run that now. It should take a while and it will tell you successfully mounted. Okay, you see that mounted at content drive. So now you have access to this Google my drive folder, the main folder in your Google Drive, this folder. But now how do I change back to, I need my files to be saved in this folder, not the main root folder, okay? So I need to change directory so that I can set up my Colab to store and access the files from this folder only. And for that, I would have to do this additional step. I will import OS module. And
just a quick question.
Yes.
What does mount mean?
You're just connecting to your Google Drive, basically.
Okay.
And your Colab account that you're using should match with the account on the drive that you want to save. That's all. So here I'm giving the directory name. From content drive, I have a folder, my drive folder, and then there is another folder within that, Python 101 training session, right? So my drive, Python 101 training session, you see that on the screen? That directory is what I'm providing here. And then change, so this is just a name, right, variable, and I want to use that variable into this method to be able to change my current directory to that directory. I could do this in same line here, but I thought this would be less confusing to you. So here I'm only defining a string. That string points, when I put that in change directory module, that will use that string and point to that correct directory where I want it to go. That is all this is doing. So when I run this, no output. Now when I do ls, list all the files in there, files and folders, everything that is in that directory, it should give me everything that I would see in that folder, including Colab notebooks, other text files, CSV files, different file types. Everything should be there. Okay. So only for Colab, again, I want to emphasize this, only if you're using Colab, you have to do this step number 2. Now, let me go back here, delete some of the files. So I want to get rid of this CSV files, get rid of this names.txt file, and go back here, do ls again. Those will not show up here because those are not there anymore. Names.txt is there. It might take a while to synchronize, so maybe that's what's happening. All right, it's gone now, you see. Now with this, we are ready to read files from our Google Drive folder and even write new files into it. So step number 2 is done. We have access to our Google Drive and that particular folder inside Google Drive. So we're going to play around and use this open command, open and close command to open new files, create new files, and then close those files. Okay. So first example here, write to a file using open command and in a write mode. So in the write mode, we will have this W, right? Every operating system, we already talked about that. So this is the name handle here. Open this file name with write access, right? And then that handle will be stored in this variable name handle. Again, names.txt is no longer in this folder here, remember? Even with the ls, we did not see that here. No name.txt. So when I run this, it will create, if it is not already there, it will create this text file and write everything that I provide on the terminal into that file and then close that file. So let's see. What is your name? So let's give Tua first. Tom and Peter. And I don't see any more output. Now let's go back again up here and try to run this ls command again. Now this new text file is there, right? And when we refresh Google Drive, this folder, I also see that here as well. Open it to verify the contents, and you see Tua, Tom, and Peter. That's the only content there because that's the only content we put with our inputs. Make sense? Anybody confused? Again, notice the open function opens the file called file name names.txt, and then W says we are enabling write access to that file. And this code assigns that open file to a variable called file name handle here, and then file.write, that name handle.write will write each of these input that I provide from this line here into a new line of that file, and at the end I'm just simply closing that file. We have to remember to close this file handle if we are using this syntax to open a file. There we will see example where we don't need to explicitly assign a name handle.close line, and Python will automatically take care of closing the file after that. Now we saw we ran this ls command. We should see that name.txt. We saw that already. Now, okay, so next example here, I am using append method. So remember, the file already has something in it, right? From this, the 3 lines that I showed you earlier. With this append method, I should get 3 new lines, right? So let's run and verify that. Nothing changes here. All I'm doing is from the, if you compare this output to the output here, these two cells have exact copy of commands. The only change is instead of W I have A here. So let's give some new names. Parker, maybe Jackson, and Kindle. Right? Now when I do ls, I do not get new file because that file was already there. Now if I go to Google Drive and reopen that file, I should get 6 columns with the 3 new names appended on top of what was already there. Any questions?
Yes, and I have one question.
Yeah.
Like we should have a command like a ls to see the list of files, because I see the exclamation ls, right?
Yeah, that is it is coming from the core module. Like exclamation ls is maybe you can also do ls. I don't know. I don't think so though. Yeah, that would give you name error because here we are trying to say it is looking for what is ls, so it doesn't know. So exclamation ls is the command for listing all the files and folders in that directory.
I think that's just a command line prompt. For example,
yes.
It could be $, or it could be something else. Probably that's what it is.
Yeah, any other question? So that was the append mode. Now let's look at read mode. Here we are not writing anything to that file. We are just, the command is almost the same. In the read mode we cannot do namehandle.write command, but we will read line at a time. So we have read line from that handle. By using this read handle, we are reading a line at a time using this for loop. So for line in read handle, we're printing the line with end a blank, nothing at the end. By default it will go to next line, but with this I'm changing that default. Okay. And this is something you will like if you are working a lot with file handling, you will get used to this. But if you are looking at this where very first time, this might be confusing to you. Let's just not have this and show you why this will give you some issue. You see this? There is extra spaces after every line, and by default print will print a new line as well. So for some reason when we read lines by this way, there is new line added, and then there's new line added after print statement as well. So that will create 2 new lines before the next line appears. So to avoid that, what we do is suppress this end equals to a blank or default next line in the print command. And now when we run this, we get a clean output. And always at the end we have to close this, because without that we are storing that read handle in memory for no reason. I think if we avoid this, it will give you a warning saying it hasn't been closed or something. Yeah, it doesn't show any error, but it would usually show a warning. So just something to keep in mind. You're just keeping the file open and that's always a bad practice.
So Sam, I have one question, right?
Yeah.
So let's say maybe we are appending something on that name.txt file and we are not closing that one, right?
Yeah.
So if we do that, it doesn't append the files in the drive.
It doesn't append the file.
It doesn't append the contents of the file in the drive. It only shows the contents that is appended in the memory only.
It is without this line. This is the append, right? The previous example. Without this line, what happens is I think they get append. The lines get appended, but the file will stay open. So if some other program is trying to access the file, then there would be a trouble because that file is already opened by your interpreter.
Okay, but even if we don't do that clause, that command, right? The file will be written in the drive as well as the file will return in the drive as well, right?
Yeah, let's give it a try. Okay, so we have 6 columns so far, right? I'm just appending maybe another garbage stuff there. Okay, and I haven't closed it, so this one was comment. This did not execute, so the file is still open. And let me refresh this just to be sure. Nothing new?
Nothing, yeah.
Yeah, so let's close this. Just run that close. I don't want to run everything again. And then go back here, refresh. And now we have those.
Okay, so basically it doesn't write in the drive if we don't close the option.
That and the file is still open, so other program, like later on, you won't be able to access that file from somewhere else.
Okay.
So read mode, we're just running it again, and we will see all those, the one we just entered as well. So that's all about simple syntax of opening and closing file with open and close commands. Now there's a better variation of this with keyword. We are using with keyword to automatically close the file, and that syntax looks something like this. With open that file as file handle. So this is just by doing as file handle, we are just creating an alias variable. Instead of assigning this read handle, we are doing as file handle, and file handle.read lines. Okay, so we are reading lines, and for every line in that lines, we are printing that at a time. And in this case, I'm also adding title here, just in case something was small letter when I entered. And by default, there is nothing here. So by default, this is read mode. So it only reads the file. Now, in addition to the names, it is giving me hello. And then the names are in title case. The first letter is capitalized with this title command or method. Again, remember, end equals to this empty string. That will reduce our empty lines or line breaks in between each of these lines. Any questions on this? Now this previous case could be even further simplified. The variation here is where instead of defining this here, we're saying for line in file handle, where we are using rstrip to remove the blank line at the end or blank space at the end, and then splitting by comma. So this will give us the list, and for that every time I am printing the first item. If I do not do row 0, it will look like this. So every item is read as a list of itself. So in this list there's only one item. To get that item I have to provide index number of 0, and we get that. Okay, the next example is reading from a file and printing them in sorted order. Nothing drastically new here. We have a new list here, names equals to new list, and then we are doing the same read command with using with keyword. For line in that file handle, we are reading new line with rstrip and split, and then again we are getting the row, the first element of that with title case, and for every row we are appending that value into this empty list, and then we are using this for loop to print them in sorted order. So we will print this again, but in sorted order, alphabetically. Okay, so that was text file, but Python can also handle different file types. I'm giving you another example here. A common file that we are gonna use, or people are commonly using, other than the text file, a more useful file type is the CSV file, which stands for comma separated values. So in a CSV file, it looks like a text file, but every element is separated by comma, and that CSV file could be handled using Excel or other softwares. Python has also some mechanism to handle those CSV files, and we are going to see some examples here. So first example is using CSV module to write data from a list into a new CSV file. So I have to import CSV module. Here's a list of students, and in that list I have dictionary elements. So each row you see here, this is a new dictionary element, this is another dictionary, this is another dictionary, this is another dictionary. So I have 4 dictionaries listed, bundled together in this list called student list, and those dictionaries are separated by commas, obviously. And if you look at inside the dictionary, I have two key value pairs. First key value pair is for the first name, second key value pair is the last name of that student. So for each dictionary there is first name and last name stored in a key value pair within each dictionary, and then they are bundled together as a list of students. Anybody confused with the syntax? It's a list of dictionaries basically, and the dictionary has key value pairs of first name and last name. So what I want to do is I want to store this in a file somewhere. Okay, the file name is student.csv, and obviously I want to write it, so I need w let's go back to our Google Drive and see if this student.csv is already there. Let me refresh this, and the only file that I have just created is text file. I do not have any CSV file here. So with this I should get a CSV file with this student.csv file in that Google Drive directory, and what I should have in there is CSV file.write command will write the first name and last name from the dictionary. So this line will just create the header for the CSV file, the first line, and then we are using dict writer. Dict writer is a method in CSV module. So we are doing csv.dictWriter and providing the file name, which comes from this alias here, and then field names within that file. So the field names will be first name and last name. So there will be 2 rows for each, 2 columns for each row of student data. The first column will be first name, the second column will be last name. And those in the CSV, everything will be separated by commas. So in a for loop, I'm writing that with write row method. For student in the student list, for every student in this list, I will write a row for that student in the CSV file. When I run this, I should get a check mark, and now when I refresh this page, I will get this new file here. And by opening this, I can verify the contents. That should look something like this. It might be too small for you guys to look at. Let me zoom in. So the first line is just a header. Now CSV file almost looks like an Excel spreadsheet when we open it in Google Sheets. So this is just the header elements, 2 columns of data, and for each column there are 4 first name and last name, and all of those are coming from this list that we had here. So this is basically showing you how we can store information from variables into a file, external file outside the interpreter. Any questions on this? Here we are leveraging the built-in functionality of DictWriter. If you notice here, I explained earlier DictWriter. This is a built-in functionality. It only handles dictionary data types, and it takes 2 parameters again, the file name and the field name. Before that, we wrote something into the file, the CSV file. We wrote the header elements, and with the writer object, we're doing writer.write row to write a new row for student data every time in the loop. Quite literally, we are telling the compiler to write a new row with 2 fields, first name and last name. Okay, so I have a few more examples. The next one is CSV module's reader method to read data back from the CSV file into a list. So now we already have CSV student.csv. We verified, opened the file and verified the contents. Now I want to read from that into this new list called students. This is an empty list for now, but with the opening the file and inside this for loop, I want to get data from there and store or append that rows of data into this list. And then later on I will use a different for loop to print those. So we got the header information and we got the students information, 4 rows total. So with these 2 examples, you see how we can, once we have the variables stored in our workspace in a Python interpreter, we can store that variable's contents into external file and also extract information from that external file and load into our interpreter. Now last example involving CSV is modules DictReader. We had what here? DictWriter in the previous example. The CSV module comes with different methods. These are the most popular one, DictWriter, and then here we used just the reader, csv.reader, and then now in this example I'm going to use csv.dictReader. So it will, this is a slightly better way of just handling a dictionary data type rather than using the reader method here. So in this example, again I have student as empty list. I'll open that student.csv as CSV file. So that's my file handler. And I will also create a reader object with csv.dictReader with that file name you provided as argument. And for row in reader, I want to append into that student list one at a time. and then print it afterward. Look at, like, compare this with this, how simple it looks, right? It looks much simpler, and for every student I just want to print student. Straightforward. Here I have to take care of the elements or index in the dictionary. So with dict reader it becomes a little simpler. Now I'm outputting dictionary data type every time because I'm using dict reader. Any questions so far? Alright, if there are no questions, I just have one more example, and this is going towards, I would say, how to manage large set of data. So far only we have seen is like four rows of data and maybe 2 columns, 3 columns. The next example I provide is a little bit lengthier. I'm just trying to give you an idea on how this works. I'm not providing you a very large data set, but just trying to show you how we can handle large data set with this method. Okay, so again, this is import CSV. I have a list of scores, and in this case I have first name, last name, and then score. So three columns for each row. And with open student score.csv, now that this file is not there, so I have to write it, and this is my file handler. That CSV file dot write, I will write the header column here, or header row, the first row, top row, and dict writer I am writing into that dictionary. So I'm basically with this, this is very simple, similar to the previous case. I'm not reading back from the file yet. I'm only creating a new file with larger than the larger data set than we previously had. So let me quickly run this and show you what the file looks like. So now I should have new file, student score, right? Student score CSV. So this is the new file. And now instead of 2 columns, it has 3 columns with a numerical column, by the way. Previously we just had file first name, last name, only 4 rows. Now we have more rows of data and more columns, including numerical column. So to handle large data set like this, I'm just considering this as large data set. Okay, this is not very large, but I'm just providing you an example here. Suppose we have a very large data set, something like this, in a larger scale than what I'm providing you here. There's a module or package called Pandas that I introduced you in 2 sessions ago, that has a read CSV method that easily handles this kind of large data set, and it's very simple command. Here we are just using data frame dot read CSV. So every time we are using pandas, pandas import information as data frames, and data frames are nothing but tabular data in 2-dimensional or multi-dimensional data structure, something very similar to spreadsheets, like columns and rows of data. So again, read CSV will take one input. The input is the file name itself, and it will store it as a data frame. And with this call, we are just wanting to print the data frame, and it will quickly read everything in that file and show you the tabular output here. And if you realize, this is much simpler way of handling that CSV file and getting the data quickly loaded into your Python interpreter, as well as seeing the output on your console. And the beauty about pandas is it is especially built to handle large data frames or large data set like this. And it comes with a bunch of many methods that are very commonly used in data science, data analysis, and all those more higher level of courses. Or for basically for data analysis, data visualization, we use pandas data frame. And I'm just going to give you a quick example of few of those. With the describe method, it gives me quickly the count of how many rows or information there are. If there are numerical elements, numerical rows like this score, it will give me mean, standard deviation, minimum of those values, 25 percentile, 50 percentile, 75 percentile, the max value, and all those. There are also other methods that you can get more statistics about from the data frame using those methods. But the describe method quickly gives you most commonly used information. And then if you want to print a particular row of data or particular column of data, then there is iloc. You have to provide the row number by index, and then it will give you all the information from that particular row. So row number 2, index number, this is the row number 2, right? So Ron, TiVo, and 79. So that's what you're seeing, Ron, TiVo, and 79 from that row. And if you want all the first names, you give the index of the first name for the data frame, and it will give you a printout of all the first names. Harry, Ron, Tracy, all these information. Only the first names. So this is not something that I would typically cover in introductory Python course, but I'm just giving you a glimpse of what you will have to deal with when you are going to more advanced topics like data analysis or visualization or just gathering information, reading lots of data into your program. Any questions on anything that we discussed today?
So for the data analyst or data scientist, I heard that they use Python to some extent. How would they use it? What would be the utilization of Python in that scenario?
Okay, there are multiple modules. One of the sessions I had a slide where I showed all the popular modules that are used for different types of tasks Python are used in. Python is one of the, like, I would say not is one of the, but the top programming language today for data scientists and data analysis.
Okay. I think as we move forward, this is just the beginner's course, right? If we
Yes,
yes. As we move forward, probably we'll have more exposure to.
Yes, and I want to take you back to the topic that I was referring to. So here I had a slide. Remember this slide? So in the middle, this is where we are, I would say, right? The core Python topics or concepts. And from there, once we learn these core concepts, we would go to one of these paths that is most interesting to you particularly, each of you, right? Some of you might be interested in web development. Some of you might be interested in like testing, automation. My favorite obviously is data analysis, web scraping, AI and machine learning. Visualization is also here. So this is where my interest is. It doesn't have to necessarily be all of your interest as well. But this slide gives you this idea of where Python can be used in today with the modules we have today for Python for all these tasks. So again, this I would say we are not anywhere like in terms of selecting any of these particular topic as of now. We are just understanding the core Python concepts, and then from there you have to pick which module you want to learn.
Yeah.
Or which field you want to go to, and then pick modules accordingly.
Right.
So there was another slide here, this one. I don't know if you remember this slide or not, but every of those fields, I listed the 4 most popular modules that are available today For web development, there's Django, Fast API, Pyramid, Flask. Flask is the lightweight version. Django is where if you want to build a full-fledged website, then you would pick Django. For data visualization, again, there is Matplotlib. You see pandas coming here.
Yeah.
And Seaborn. Matplotlib and Seaborn are mostly used. Plotly is also getting more popularity, but these are the mainly modules that will give you plots like bar charts, pie charts, all these scatter plots, histograms. And for machine learning and artificial intelligence, these last two are there. Like earlier I mentioned Skitlearn, TensorFlow, PyTorch. Some of these are created by Google, Facebook, all these big companies.
Hey, what is machine learning?
Okay,
What does that mean?
Machine learning is a field where you will train the computer to do some stuff without explicitly telling the computer what to do. So based on certain observations, the computer will determine what is wrong or right, or what to do or not to do.
Is it like something close to AI thing, or
AI? I would say AI is the bigger
picture?
the whole grand picture, and machine learning is just a portion of that.
Okay.
So people tend to say AI and machine learning, AI ML together. If you guys are interested in any of these topics, just let me know. I'll try to accommodate.
Oh,